Hi, everyone. Welcome to AgriBusiness Global Live. My name is Renee Targus, and I'm the editor for AgriBusiness Global. I'll be your host for today's webinar, Drones and Sensors, Future Effects on Agrochemicals. We've got a great panel this morning. I'm very excited to have them all here, but we're also very excited to have you here as well. And I just wanted to let you know you're a part of this discussion. So if you have any questions, please put them at the bottom of the screen. You'll see a Q&A section. Just put your questions in there. We're going to be holding those questions until after the discussion, and then we'll take the questions in order as they're received. If we don't get to your question, we'll be putting them into a blog and having our experts answer them. And then we'll be posting that blog along with this recording of this webinar. So we just want to make sure that you understand that your questions will get answered. So feel free to please participate in this discussion. So we've got this great panel. I want to introduce them just to let you know we're going to be sort of sectioning off this discussion in two parts. So we're going to start with drones, an overview and about the technology, and then we're going to go into the formulation side. And I'm going to introduce our speakers as they will be speaking today. So first, we've got Rachel Lowe. She's an analyst and junior partner for AgBioInvestor. She specializes in climate and weather analysis. From the ag tech side, we've got Arthur Erickson. He's the CEO and co-founder of Helio. Helio designs and manufactures drones used in agriculture. We also have Derek Oliphant. He's the co-founder of AgBioInvestor, and he heads the crop protection analysis division. Derek also contributes to each issue of AgriBusiness Global Direct as our crop protection special reports for our different regions. We also have from the formulation side, Scott Tan. He's a North American business manager from Lamberti. He's also the subcommittee chairman for the ASTM E35.22 subcommittee of pesticides, antimicrobials, and alternative control agents, and the co-chair of BPIA's organic subcommittee. And then lastly, but not leastly, we have from our regulation side, Dr. Pietita Pucle. She goes by Tung, so I'll be addressing her by that name. And she is the regional sales and regulatory policy manager for NOL. She recently wrote an article on drone regulations in the AgriBusiness Global Direct September issue. That's coming out September 1st, if you'd like to read that. She's also an advisory board member for the AgriBusiness Global Southeast Asia Conference taking place on November 8th and 9th in Jakarta, Indonesia. You can learn more about that event at abgseasia.com, and we hope to see you there. All right, well, let's just get into it. We've got a lot to discuss today. So Rachel, I'm going to pose the first question to you. Can you give us a high-level look at the adoption of drones and ag tech globally and what you think the projections for growth might be?
Yeah, of course. Thank you very much. Thanks for having us. So I'll really just kind of give a broad overview of the current environment for drones in agriculture. So as most of us probably know, the agriculture sector is facing an increasing number of challenges, things like population growth, urbanization, dwindling natural resources, environmental degradation, climate change, extreme weather events, just to name a few. So if we just look at the world's population, in 2022, the population officially passed the 8 billion person mark. I mean, that's a huge number, and that represents more than 3 times the size of the population in the 1950s. And not only this, the population is expected to continue growing out till as late as about mid-2080s, where the population has the potential to surpass 10 billion people. So feeding so many people has been, and it will continue to be, one of the main drivers of demand for agricultural produce going forward, particularly for your food grains, your rice, your wheat, your maize, etc. And combine this with things like land degradation, climate change, urbanization, there's a growing need for new strategies to help farmers produce more, often using the same amount of land or less land due to things like desertification. But we also need these strategies that prioritize sustainability and resilience. So digital and precision agriculture technologies, including drones and sensors, have been identified as kind of a key component of meeting these challenges. So in agriculture, drones have a number of applications, just looking at this very high level, one of them being they can be used for scouting and mapping, gathering on-farm data. This can provide growers with insights into things like crop health, pest and disease occurrences, and can be used to help with decision making. In addition, they can also be used for the application of crop protection products, spraying fungicides, insecticides, herbicides. That's coming up a little bit now, and a variety of other products. So there's been a notable increase in activity in the agricultural drone market. We've certainly noticed it. We publish a daily news email every day, kind of rounding up the latest happenings in the crop protection and seeds and traits industries. And we've certainly noticed the number of partnerships and collaborations to do with drones increasing rapidly. A lot of the major multinationals, your Cortevas, your Bayers, your BASFs, etc., all of them getting increasingly involved in this space as well. And just as an example, we've had recently Bayer, FMC, and Adama all launching drone spraying services in India. Syngenta as well has received approval to spray, I think, at least 2 of its products using drones in India as well, and has also actually begun a drone spraying pilot program in Pakistan. So quite Asian focused at the moment, but we are seeing a ramp up in activity. And drone spraying is not just limited to conventional crop protection chemicals. A number of companies in the biological space are also becoming involved in drones. So as an example, bee vectoring technologies, also known as BVT, they recently partnered with a company to trial drone applications of their biological fungicide on a number of crops. And then you've got other big players like Koppert Biological Systems. They've actually developed their own drone, the Naturtech drone, I think it's called, which is designed to release a range of biological organisms over large kind of areas. At the moment, only one of Koppert's products can be used with that drone, but they are expanding that out. So the products that are being dispersed by that drone are actually macrobials. So one of their products, Spidex, it's based on predatory mites. So those are being dispersed using these drones. Moving on to look at some of the major players in the industry at the moment, we have the two big ones, DJI and XAG. So both of these are Chinese companies. DJI, technology company, one of the leading commercial drone companies. So initially, they just manufactured commercial drones for aerial photography and videography. And in 2012, they made the decision to expand out into agriculture. And since that point, agricultural drones have become a major business for them. And I think here, it's noting that they've introduced at least 2 new agricultural drones to their portfolio every year since 2019. So they're investing heavily into this area. Sales of their agricultural drones have expanded rapidly. And as of September 2022, total sales of their drones exceeded 200,000 units. So they're selling a lot of agricultural drones, and it's just expanding year on year, adding up. And they report that in 2021, their agricultural drones serviced a total area of more than 65 million hectares of farmland. So large areas being treated, and this is globally, not just in China or in Asia. This is globally. Not necessarily just spraying drones, but can include scouting drones as well. And then the other player, XAG, another Chinese company focused on kind of automation and unmanned devices. In 2022, they had about 110,000 unmanned agricultural devices, including drones, in operation globally, and that's covering an area of more than 95 million hectares. So there's big potential here for drones going forward. Moving on to some of the key markets. I mean, we don't have time to go through them all, so I'm just going to mainly focus on a couple of key ones. We have Japan. This is a big market for agricultural drones. This is the country where drones have been used in agriculture since the 1980s. So one of the biggest challenges this country is facing is a chronic labor shortage. We have a declining population, and the number of key agricultural workers has actually fallen significantly. According to their latest census, the number of key agricultural workers in the country declined by 20% in the 5-year period between 2015 and 2020. And this number has continued to fall by around 50,000 people each year. So they're really, really struggling with labour shortages at the moment. On top of this, not only are they losing key workers, but the key workers that remain in the agricultural industry, their average age is rising as well. We're seeing an aging demographic here, with approximately 70% of their key agricultural workers over the age of 65. So to combat this, to maintain and increase agricultural productivity in the country, whilst dealing with labour issues, Japan has placed a huge focus on smart agriculture, promoting smart agriculture. And a big part of this is promoting the use of drones as kind of a labour-saving mechanism. So as a result, we've seen kind of an explosion of adoption in Japan recently. In 2020, the total area treated with pesticides using drones in Japan almost doubled over the previous year, coming up to about 120,000 hectares. And what's interesting is it's not going to stop there. Japan has actually stated that they want to increase the total area treated to 1 million hectares. So they've got big plans for this technology going forward. On the other hand, we have Western markets, places like Canada, where the market for drone spraying is very much still in its infancy. According to census data, less than 4% of Canadian farms currently use drones, and that's in any capacity, for sensing, for scouting, anything like that. And the majority of this use is for scouting and mapping. Although we are seeing changes, Canada has recently approved its first products for use for application by drone. These are 3 biological larvicide products from Valent Biosciences. So we're starting to see changes there. And then similarly in the US, adoption rates still quite low, but we are seeing them trend up. According to the USDA, we've got 7% of the country's maize area utilizing drones, aircraft, or satellites, or a combination thereof. So not just drones, but kind of aerial imagery and drones as well. This number is actually slightly higher for soybeans. About 9.8% of the total US soybean area is reported to be using these technologies. So the rates of adoption we can see they vary widely between countries and regions. Asia currently, I would say, the front runner. But we are starting to see some momentum coming in some of these other markets, the US and Canada. Europe slightly behind on that. Regulations are quite tight, but we are seeing little changes. So it'll be really interesting to see how the market evolves going forward. I mean, I can see a lot of drive for new technologies coming from environmental policies and sustainability policies. The EU's Farm to Fork, the USA's agricultural innovation agenda. These kind of things very much have the potential to drive adoption if proper guidelines are set out and there's plenty of investment and demand, which I think there will be. So it'll be very interesting to see how the market develops in the next few years.
Thank you so much. That's a very thorough answer. And I've got some follow-up questions with you, but I'd like to get through all the panelists first before asking them. So Arthur, I'd like to pose a question to you since you're the expert in our drones. So can you talk about what's changed in drone development in the last 5 years and what the future holds for these developments? I know that before, I think they can have an increased payload. There's a lot of different aspects of them that have been, I think, making them more attractive to farmers. So could you please talk a little bit more about that?
Sure, yeah. So to talk about where drones are going, we'll talk a little bit about where they've been, right, in the past, as you said. So even further back than 5 years ago, you have your first lithium-ion batteries with cell phones, right? So those are only 80 watt-hours per kilogram, so not very energy dense. Those improved, basically got to the point recently in the last 10 years or so where you're at 200 to 250 watt-hours per kilogram in battery energy density. So why the batteries matter, of course, is because the batteries power these drones. So it used to be, when I started this business about 9 years ago, a battery couldn't even give you a full payload or tank's worth of flight time. So to even just spray 2 or 3 gallons out of a spray drone, you'd maybe have to swap the batteries once or twice, depending on what quality battery you bought. Now in 2023, the batteries are so good, like I said, close to 250 watt hours per kilogram, that you could actually get several payloads worth of flights out of a single battery charge. Now that matters because quality of life using these machines, how intuitive they are and practical they are, matters a lot for these things to be adopted commercially. So now we can tell people, hey, you only need to buy 3 or 4 batteries and you could run your drone all day. You don't need 300 batteries. So that's a big change that's happened over the past, 10, 20 years, starting from cell phones all the way to now. Electric batteries, lithium polymer batteries, I should say, being used in drones, but also all sorts of technology. So that's a big change recently. Another thing that's fueled the advent of autonomous drones recently is the continued micronization of computing processors, computers, essentially. So you've got like your cell phone, right? I've got this iPhone. It's got a really accurate GPS in it. It's got accelerometers. It's got a great camera. And this is all packaged in a small, like 2-pound device, right? 1 or 2 pound device. Now that the industry surrounding that, the ability to create those devices has obviously transferred over to the drone industry. So now you've got drones that aren't dumb, right? You have drones that are actually intelligent. They've got a flight controller on there that can map out, detect obstacles as it's flying. It could identify weeds as it's flying, store all that information, process it through advancing algorithms, and make intelligent calls out there as it's operating. So that's fueling the practicality of drones in the other regard, because they're becoming more autonomous and thus more user friendly, right? So that's finally taking us to the point where the drones are both energy dense enough with their batteries to actually go out there and do practical work all day, but also easy enough to use because they're smart enough to where you as a farmer can just say, hey, here's my field, here's my 200 acres. I want 2 gallons per acre. I want you to fly at 20 miles per hour, 10 feet above the crop. Click go, and it can do that reasonably. So it's not like an RC helicopter from 10, 20 years ago where you're standing there manually controlling it, toggling the pump on and off. So that's where drones are today. They're autonomous, reliable. Energy density is there. It's still room to be improved. Obviously, you still need to swap batteries, which can be a little annoying. A lot of our customers, a lot of operators cite that as still being one of the pain points of the process, having to have a trailer where you're charging batteries and swapping them. But like we've talked about, that's increased in energy density about 3x over the last decade or so. And so I do think that's going to slow down a bit. There's not so much more you could squeeze out of lithium polymer batteries, but probably at least another 30-40% efficiency. So what that's going to do is that's going to allow us to have even bigger drones, right? So the direction is, right now you've got drones, the biggest you can find, like we sell one that's about 18 gallons. That's probably the biggest spray drones you could buy right now. That's about 150-pound payload with slightly better batteries, just a little bit better. You could get up to 30, 35, 40 gallons pretty comfortably. And then we're talking about batteries that aren't massive. Hopefully, you can't ask customers to carry 200-pound batteries to and from their drone every 10 minutes. So that's why that energy density is important to continue improving upon. So you get reasonably sized batteries for these 30 to 40 gallon drones. These are big machines that are going to be able to do thousands of acres per day. So that is rivaling current ground rigs, tractors, even helicopters and planes in certain reference frames. So a plane is going to be able to do thousands of acres if it has wide open fields. But if a plane has to navigate small patches, then it's going to slow down the efficiency. So once you have these 30 to 40 gallon drones, you're doing some serious work. I don't think they'll get much bigger personally, because if you get bigger than that, then you're helicopter sized, and that's introducing a lot of problems that you have with helicopters, which is they're expensive, difficult to maintain, higher risk, right? So they'll get bigger. But also with the advancements in the computing technology and miniaturized cameras and stuff that we talked about earlier, they're going to get more autonomous. So you might have 3 or 4 30 or 40 gallon drones out there operating from a centralized location. Think of like a big shipping container that has automatic battery swapping. It's got automatic payload refilling. It's got scout drones, so camera drones inside of it, as well as the heavy lifting payload drones. And this hive or nest of drones operating completely autonomously, hands-free. You drop it off as the operator or as the farmer. You drop it off in your field at the beginning of the week. You define like a 5,000 acre area for it to treat, It's going to go out, detect what areas need what products. It's going to dispatch the payload drones to go spray those areas. And then you come back and you pick up the shipping container or the nest in 5-6 days, and it's all done. And then you plop it down on another farm or something. And so that automation is also going to transform the way that customers or industry adopts this economically, because if you have a system like that to where these drones are so efficient and so automated, you basically don't need to have every single farmer owning a drone, right? These drones can kind of travel between farms. So I think you'll start to see adoption from the biggest players, like the biggest chemical retailers, like maybe let's say Nutrien, but even people like John Deere, Case IH, like these manufacturers of drone equipment are going to be investing in these large scale drone hives or nests, and they're going to lease those out to people. And that's going to be more of like a seasonal thing where you rent it for 3 months or something like that. Anyway, yeah, that's my 5-10 minutes on just where the future of the drone industry is going to go from my perspective.
Thank you. I just had one quick question. So when you're talking about the drone nest, how far is that now, or is that how far in the future is that?
You already see it in its early phases now. So people are able to pull off like an automatic refilling and charging station, but it's one thing to do it in an engineering setting, like once in perfect conditions. To do it across the 1,000 of edge cases that happen in the real world, that's difficult to achieve. So that's going to take probably 2 or 3 more years of really hardcore real life testing to actually make sure that works in every case imaginable. Because the last thing you need is, for the drone to be going well, 50 flights, and then on the 51st flight it lands kind of cantilevered or something, just like off the thing a little bit, and then boom, like it's a disaster. The drone tips over, you lose all your chemical, and then you're done for like a week or something. So you can't have any mistakes. That's the hard part. Just the absolute reliability of these things has to be spot on.
All right, well, thank you for that explanation. So now that we've kind of got a sort of a base understanding of kind of what's going on with drones, I'd like to go kind of switch the discussion over to the formulation side. And so, Derek, I'd like to pose the question to you as kind of an overview of what you're seeing as the opportunities for formulations, or what kind of formulations you might be seeing globally.
Yeah, sure. Thanks. So maybe just first, I'll just touch on sort of why growers are still adopting these drone technologies, because after touched on the technology is now at a point where they're being more widely adopted. So why would the growers start to use these in such a big fashion? And of course, Rachel touched on, in Japan in particular, is the issues around labour. But we're also seeing that in a lot of other countries now as well, where it's much more difficult to get people into your field to apply technologies, etc. So we are seeing drones obviously replacing labour in a lot of cases. And we're also seeing, leading to volume reductions, which are a huge advantage in today's sort of regulatory environment. And that ties into the formulation side of it as well, where these drones, because obviously Arthur touched on it as well, is how big the storage tanks on these devices can be. So the formulation that you're putting in this system be much more concentrated than what you're normally applying in a sprayer. So there is obviously challenges to be met here. And then that brings on other issues as well, such as what you're looking at with these drones is, Arthur touched on it again, is how far above the field these drones are flying, how much distance they have to cover. You also have to take into account what the sort of weather conditions, etc., would be as well. So when you're talking about formulations, there is challenges that have to be met in order to apply these products precisely and accurately to crops when they're using drones. So, for example, you have to pay particular attention to droplet size, because if you start using droplets that are too small, they'll just get lost in the wind and blow off target when you're flying so far above the field. You also don't want to make the droplets too big or too heavy, where they'll just bounce off the leaf, for example, and adhesion will be a problem. So there is these type of challenges that need to be met as well. And then on the formulation side as well, you're also looking at, Rachel touched on it a bit, that what you really need is separate regulations to apply products by drone as well, because of the different formulations and concentrations that you have. There's a different sort of regulatory branch that you have to go down to get your product approved for use in drones. So obviously with that, there's a cost attached to get a regulation. Obviously there is an outlay that you have to pay in order to achieve that. So what we're seeing is these more advanced technologies, and these ones that I've talked about, they typically come with a price premium as well. So there is opportunities for companies who can be at the forefront of this new formulation technology, that they can uplift the value of their crop protection active ingredients through these sort of more advanced formulation technologies. And of course, when we're looking at issues now around volume reductions, etc., and regulatory restrictions on certain active ingredients, it does limit the value generation that could be had for mostly, for example, for generic crop protection companies that are looking at older molecules that are typically larger in size than some of the smaller molecules that we're seeing coming through from R&D now. And of course, if you can overcome the challenges around off-patent products through advancements in formulation technology, then this gives you a big benefit over your competitors, where they're offering sort of much more generic white label type products that are just standard formulations. So it does give opportunity for, particularly for generic companies that want to be involved in the drone sector, that they can get a lot of value enhancement and value uplift through these sort of more advanced formulation technologies that are necessary in order to apply these products through drone application.
All right, thank you. Thanks for that overview. And so, Scott, I'm going to kind of switch this over to you, because you're kind of in the mix of like what formulations are, and where's the industry as far as creating formulations for drones, and what are the challenges and some of the opportunities? And I just wanted to remind you to take yourself off of mute. Yeah, thank you. All right.
So thank you, Renee. Derek touched on a lot of the key high-level principles, but I think a lot of this is the devil's in the details. The formulations, he's already touched on the fact that formulations are going to have to change. And I would say we are in the infancy of formulation change for drones in one respect, but in another respect, we've been there before. So in the 1990s and early 2000s, we had formulations moving toward ULV applications. And the reason we were doing that back then was there was a lot of concern about water usage. We were still running 100-gallon tanks over the field. People were very concerned about wasting water, too much water going into agriculture. States like California were looking at regulating the amount of water being used. So people started developing ULV formulations. Fast forward to 2020. Now we're being asked to carry payloads, as Arthur has said, 18, 20-gallon payloads. We're seeing application rates in Brazil as low as 2 liters per hectare. So you're looking at highly concentrated formulations, as Derek alluded to, but it's not just highly concentrated, it's really ULV formulations. And that's a game changer for formulations. So we're going to be seeing a lot of art and science going into formulation development in the next 5 to 10 years to meet the drone demand. Is it possible? Yes, it's very possible. Do we have all the tools we need? No, we don't. And some of the principles that we might have applied in the past are going to have to change to the way we think about things. Derek mentioned drift and droplet size. Well, drones create downforce. We don't see that with aerial applications. We don't see that with the ground applications that we're traditionally seeing, because there's nothing driving the droplet downward other than gravity. In a drone, that's not the case. So the droplet is going to be driven down by downforce, which is going to change all of our parameters around droplet sizing. We're used to operating in water-based systems with water-based polymers and water-based drift agents that are very hydrophilic and give higher extensional viscosity, thus giving bigger droplets. Drones are going to change that. We're going to have hydrophobic drift agents that are going to change with the formulation types, because there may not be any water present. We're going to have regulation issues, because now we may need solvents. I mean, we had solvents back in the 80s and 90s that were fantastic solvents, but they have huge environmental impact. Monochlorobenzene was widely used. It was a very popular solvent, but nobody in their right mind would use monochlorobenzene now, because there's not a regulation in the world that would allow you to put chlorinated benzene out. So there's going to have to be some solvent evolution as well, as to what are we going to look at in solvents. And we're going to need our regulators to work very closely and think about that risk and exposure quotient around the toxicity of the solvent, because we're reducing the exposure greatly by using the drones, but the risk is still there. So how they manage that and how fast they can manage that is another big issue that we're going to have to worry about. So there's a lot of, I can go on and on, but the basic there is there's a lot of change that needs to happen. A lot of ways that we think we're doing the right thing today will not apply necessarily to a drone. So new solvents, new formulation types, higher concentration of active ingredient, better deposition. The adjuvants that we've used in the past, the tank mix adjuvants, the wetters, the stickers, the crop oils, all of those things were designed for large application volumes. They may or may not fit the drones. You may be needing an adjuvant that is very specific to your active ingredient rather than a general purpose wetting agent. So all of those things are going to have to be looked at. And it's exciting because from a formulation standpoint, there's a lot of opportunity for development and new products.
You're talking mostly about like the synthetic crop, chemical crop protection chemicals. What about biologicals? Do you have anything?
Yeah, it's a great question. Biologicals, one of the key in the biologicals is a lot of times those organisms, you can't use the traditional materials because they might disrupt the cell or they might act like a surfactant acts, where it actually is bad for the biologicals. So drones will actually give us the opportunity where we're going to be able to formulate those biologicals in systems that may or may not use water, preferably not, so that they're not affecting the biologicals. If you go to the biological excipients, some things like pheromones and micronutrients and things like that, drones really give opportunity. Just one example that I can give is we spray right now with helicopters on fruit and nut trees. A lot of that spray is intentioned for the tree, right? And a lot of times we get maybe some, we try to limit, we've got drift agents and everything else to increase deposition. But if we could put a drone that can selectively spray just on the tree, right? Then you've got something that is an opportunity for your biological, because if you're doing mating disruption with pheromone technology, that mating disruption, if you spray it general purpose out on the ground, it's not going to be as effective as if you spray it directly on the tree where you're trying to get that to occur. So it gives you the opportunity to pinpoint your applications rather than broadcast your application, even for freeze control. I mean, we do a lot of air blasting for freeze control, and that we wouldn't need to necessarily do that with the drones. But back to the biologicals. Yeah, I think it's a big opportunity for the biologicals because you can get on target better. You can put it where it needs to be, and you may not have to disrupt the cellular tissue as much as would be in a water-based system.
Okay, great. Thank you. All right. So our final panelist that we'd like to ask about Tung is regulations. So looking at regulations, it looks like different regions are doing different adoption rates of drones. And then we've got the formulations. Can you give us an update of kind of what you see going on as far as drone regulations and formulation?
Sure. As Rachel already mentioned that there are lots of movements in Asia countries where many of multinational companies and also local manufacturers like Chinese or Indian manufacturers are actively involved in those drone formulation or pesticide for spraying drones. I would like to give some more input or some updates regarding the regulation for drone formulations, because in Asia countries, you will see that almost all countries, they have some guidance or some SOP or even upcoming regulations regarding the spraying drones formulation. So first of all, talking about the drone formulation, of course, those products must be registered products. And there are two cases for drone formulations. First thing is the existing formulation, for example, those EC or SL, SC, which are registered pesticide. First of all, companies must they can apply for the label extension. And this is possible for almost all countries because those countries, they have their own regulation regarding the label extension. So the information which you need to provide is about the crop safety and also efficacy data that you have to submit. And the phytotoxicity issue should not be occurred. I would like to give some example. For example, like Japan. Japan is an industry-based practice because in 2019, the authority, which is the JMAF, they released the guideline regarding this, and it is stipulated that for a specific drone, those efficacy or residue trials are not required if it is an extension of those registered formulation from conventional spraying. Having said that, those active ingredient and dose per hectare, the PHI value, number of application is within a determined range of conventional spraying. And the company who apply for this, they must ensure that the formulation can be properly used by drone. So the first case is for those existing formulation. It is possible to do the label extension from the current formulation, extend for the drone, for the spraying drone using. And the second case is for those new formulation, for example, the ULV, ultra low volume. Of course, the registration of the new formulation is possible, but it takes time, at least for Asia countries, it is possible, but really take time. It can be 3 years or even 5 years per country. And different countries, they have their own regulation and also data requirements regarding the new formulation. A country like Philippines, they already have the list of pesticide for spraying drones, and it is also possible for those new formulation with the new active ingredient or new formulation with the current registered active ingredient. But of course, for new formulation, the specific efficacy trials, the crop safety study are required for those formulation. And not only focusing on the formulation for spraying drones, but I would say that the label interpretation and instruction for spray application are very important because the label instructions are adhered to. So label for that is very important. I discussed with some companies in China, and they said that currently in China, because the regulation for drone in agriculture is not that strict, so most of the farmers, they use just the pesticide, like those generic products available in the market, and then they apply for spraying drones. But of course, they put some adjuvant. And talking about the adjuvant, it is also very important to use the right adjuvant against those evaporation and spray drifting, because if you put like adjuvant which is not proper for those formulation, it can contribute to the toxic load. And of course, currently, not every country required the registration of adjuvant. However, as I just mentioned before, put adjuvant can contribute to toxic load. So in the future, the authority might also consider about the adjuvant for spraying drone. Maybe they will ask company to submit more and more data regarding the risk assessment and etc. That is what I can share. Yeah.
Okay, great. Thank you. Thank you. Thank you all for your answers. And it looks like we've got a few questions from the viewers. So I'm just going to start to go through those. Okay, so with the ever-increasing use of drones for pesticide spraying, that will be affecting pesticide regulations, including less amount. So I'm not sure exactly what the question here is for. What will be the effects of pesticide regulations? Oh, okay. What will be the effects of pesticide regulations, including less amount of water, worker protection, environmental? So Tung, I think that question is going to you. And I'm not sure if you already answered it, but do you have any comment on that?
I would answer from the Asia point of view that when we're talking about this kind of controlling, we are not at that level. So it's more like each country, they have some guidance or some regulation starting from the National Civil Act, and then they try to modify from that to cover drone in agriculture. And after that, they were talking about using the pesticide in a proper way of using, but not about worker protection or and etc. However, they also have some part of the guideline or the SOP regarding how to use this spraying drone in a proper way by having the standard operating procedure. With that they have, but not every country has the regulation regarding that. And talking about the environmental protection, I would say we are not at that level. So if you want to see like the most developed guidance regarding this topic, I would say that you can go through the guideline from Japan, as I said, because they developed this guideline from many years ago, and until now they are kind of the leading country regarding this topic among Asia countries. Yes.
Okay, great. Thank you. Our next question is, how is the upcoming export restriction from China going to influence availability, price, operations, and research? And how long do you see it lasting? Derek, I don't know, is this a question that you think you can answer, or Scott? We'll start with Derek.
Yeah, well, obviously, as Rachel touched on, two of the biggest drone manufacturers are based in China. And if any sort of trade restrictions are implemented with Western countries such as the US, and obviously it will make it very difficult for this technology to move to these regions. But we are seeing a lot of drone development in other countries as well. So there is potential in such countries such as India, where if they manufacture drones in the same scale as what's happening in China, then obviously there's an opportunity for these drones to be adopted in other countries where there's none of these trade barriers in place. So I think the issue around it is obviously it's dominated right now by China in terms of manufacture. However, the same is true of agrochemicals in general, where China is by far the biggest producer. However, we are seeing a number of alternatives to China appear, and India being the most notable. So I think we will start to see a lot more investment and a lot more development in drone production in India, but also in the West as well. As we sort of touched on right earlier, uptake in the more Western countries, Brazil, USA, Canada, hasn't really taken off in the same way as it has in Asia. And I think a lot of that is to do with farm sizes. So obviously in the US and Brazil, farms are much larger scale than what you're seeing in Japan. So it's obviously much harder to treat a huge maize or soybean field with drone technology than it is for a small rice paddy or orchard in Japan. So the adoption isn't really there in the West yet to allow for the manufacturing capacity that we're seeing in China. But I think as we start to see uptake start to increase, we'll start to see production in these countries start to increase as well. And as I said, other countries such as India, where the technology is becoming more important, obviously they will then have an opportunity also to export their technologies to other countries as well.
All right, thanks, Derek. Arthur, did you have anything you wanted to add to that? No? Okay.
No, not in particular.
Okay. How about you, Scott? Anything?
No, that's outside my world. So
Okay.
taxes
Right.
and import duties and things are not something I know much about. So
Okay. All right, great. Thank you. All right, the next question we've got is from an investor perspective. This person sees a plethora of innovation in the sector of automated robotic systems for ground level applications, but they see very few companies coming through the ranks for drone agrochemical applications. Are generic agrochemical companies really putting their money where their mouth is? And if so, is this rather a hedge against the alternatives that look to be taking the winner's medal? Is that another question for Derek or?
Yeah, I can have a go at that. So I think, again, the issue is around adoption of spraying drone technology, and we haven't seen the same uptake in the US, Canada, Brazil. It's what we've seen in Eastern countries, such as in Asia. So I think a lot of the investment side of it coming from the West is more focused on other alternatives. As I mentioned, farm size is a big issue in using drone applications in these type of countries. So that was obviously prohibitive when you're talking about, for example, Arthur was talking about having to change a battery 3 times to spray a few thousand hectares. But when you're looking at farms that are millions of hectares in size, obviously it can be very prohibitive to start applying your whole spraying program using drones. So the technology is more focused on other alternatives, such as the robotic technology that's touched on there, and also alternatives to weed control, such as electrification or burning. But I think if we start to see drone uptake increase, then obviously the company focus will start to increase as well. So I think it's a bit of a situation where one feeds the other, whereby demand for drone technology will force the companies to start investing in this. But I think we have seen in countries where uptake is quite significant, such as India, there is a lot of these generic agrochemical companies now placing much more of a focus of developing formulations and products targeted at drone technology, primarily because India is such a big adopter of this. We are seeing a lot of the generic Indian companies start to place more of a focus. So I think in Asia it's already happening, but in more Western countries, I think we need to see more adoption at the grower level before investment really takes off.
Scott, did you want to add anything to that?
Yeah, I would add a lot of the generic companies, I think, are sitting back a little bit because drones are they have the potential of changing the toxicity or the phytotoxicity of the active ingredients. So your droplet sizes are smaller generally in drone applications. When you're looking at, as I said earlier, 2 liters per hectare, you're talking about, in order to get the coverage, you've got to have a lot of very small droplets. And sometimes we've seen in the past where some of the generic herbicides, there are certain droplet sizes that are necessary for them to be effective. Whether that's a large droplet that you can't reduce the volume, or it's the other way around where it's a small droplet that makes it even more toxic to the and more phytotoxic, I should say. And in the US in particular, when you've got 80% of the acres roughly, Derek can probably give me better numbers than I could even say, when you've got 80% of the acres in the US that are genetically modified, whether they're Enlist beans or whether they're XtendiMax beans or Ingenia corn or whatever it might be, there's an awful lot of concern that you would destroy those crops with too small a droplet of the active ingredient. So the generics, even though they have the chemistry, there's going to have to be some screening just to make sure that they're not damaging what they're trying to use. And I think we're just on the beginning. I mean, that initial thrust in the US hasn't happened like it has in India, for instance, that Derek is hinting at. We've got a lot to learn in the Americas, whether that's Brazil all the way up to Canada. We've got a lot to learn because the farming practices are different, and we've got a lot more adoption of the genetic modified crops that need to be screened for, and quite frankly need to be allowed. I mean, a lot of those are proprietary seed technology, and they control what goes onto the field, and even those folks haven't really looked at drone applications yet. So we're still on the front end. There's a lot to learn yet.
Sure. All right. Well, thank you. Thank you both. The next question is just, they were asking if there's a recording of this webinar made available to participants, and the answer is yes. So we'll be sending out an email with this recording. A second question, and I think Arthur, this might be for you. What would be the effects of drone spraying on integrated pest management programs?
Well, drones are a very efficient and effective way to do IPM, right? So it's a tool like anything else. What's great about the drones is, of course, you have like that third axis, complete 3D freedom. So in a lot of ways, it's the least invasive way to go target an individual weed, like an individual pigweed plant or something out in the middle of the field. You can't really do that with John Deere Seed Spray, for example, because you're still rolling out there with a tractor and, possibly damaging crops or doing soil compaction, right? So drones are just ultimately like a really good avatar for you taking that data that you got through your various, farm IoT stuff and saying, hey, it's almost like the hand of God, right? Because you come down and strike like a single weed. And that's pretty much the only tool that can do that.
All right, great. Thank you. The next question we have is from the perspective of formulations here in Colombia, the usual doses are measured per hectare in 200 to 600 liters in different crops. We are trying to create a matrix of what works and what products create antagonism in the tank. What are your experiences with this issue in your countries? Here in Colombia, there are no access to ULV products. Who'd like to take that question?
I'll take that, Renee.
Okay.
There's like 3 questions in one question there. So first of all, the ULV situation, I think we are, as I've stated earlier, we're to the point where we need to do a lot of development work on the ULV applications. So Colombia is not the only place that doesn't have access to a lot of ULV formulations. They're in development at this point, and there aren't a lot of them out there. The antagonism question is a unique one because we're seeing multiple actives go out at one pass. So in a drone where you're limited to a very small volume, you've got a very limited amount of spray solution, if you would. Antagonisms are going to be a concern because they're still going to want to mix. Now, one of the possibilities is many of the drones have separate tanks, and you could possibly get around the antagonism by using 2 tanks on the drone. Like Arthur was saying, he's got, we've got 19-gallon drones that he's using, but there's also drones that are, correct me if I'm wrong, Arthur, but there's drones that carry 2 payloads that may be 5 gallons on each side, that you could avoid the antagonism issue by using 2 payload systems, which you can't do as easily with ground applications. So that question, there's a lot of questions in that question, but hopefully that's helpful.
Arthur, did you want to add anything to that answer?
No, just Scott's right there. There's the ability to put any X number of tanks on a drone, actually. So we could see that become more commonplace as the applications get more complicated. But yeah, no, that's all.
Okay. Derek, did you have anything you wanted to add to that?
No, I think that covers that question well.
Okay. All right. Our next question, are drones good for area-wide control? Example, SIT. And Arthur, I think that'd be for you.
Yes. What is SIT? I don't know what that is, to be completely honest. Area-wide control.
Area-wide control, do you know what that is? No.
I specifically no. Like I mean, I know what the words mean, but area-wide control. Okay. A term meaning just covering an entire region. Well, okay, I'll answer it as best as I can, not really knowing SIT is, but I think the problem is a lot of people are hesitant about drones because they have relatively small payloads. Now, we've talked a little bit about it, but drones are actually able to get away with much less payload in terms of overall solution volume than tractors, for example, because of the physics of their droplets, right? So smaller droplets, better chemical penetration. And so you're able to do more with less, simply speaking. So a 20-gallon payload drone, it isn't as small as you're thinking, right? It can effectively cover hundreds of acres per day. So when you're talking about covering entire regions or areas, which I'm assuming this is what this question is asking, yeah, if you deploy multiple drones, you can compete with traditional equipment in terms of acres per day. So they would be useful in that sense as long as you have enough of them, and automating them further, like what we do and what other companies are trying to build with just really intuitive methods for a single pilot controlling 3 or 4 drones at a time. That's going to make that even easier. But yeah, I mean, that's my answer without really knowing what that acronym means.
I can put in 2 cents here. I think part of that, when they say area-wide control, I'm assuming that means more of a broadcast spray rather than a targeted spray.
Okay.
And that might be related to things like burn down at the end of the season. And again, I would go back to the drones have the ability to use several different nozzles, just like a ground rig. And they also have the ability to use different pressures. So with the limited payload, you're going to have the right nozzle at the right time for the right application. So if you're going out for burn down application where you're trying to get it out to as much acreage as possible with the limited payload that you have, that would be a different nozzle and a different pressure than if you're going toward targeting specific weeds or specific applications for between the rows or something like that. So the same technology that we've seen used in row crop and the development of nozzles and nozzle development in row crop or broadcast application over the last 10 or 15 years, I think we're going to see the same type of nozzle technology development for drones, because they can operate the same way as a ground equipment. It's just what you ask of it to do. And we may have nozzle development specific to the formulation type and application type.
Great. Thank you, Arthur and Scott. All right, we've got about 24 questions and we've got about 6 minutes left. So we're going to continue to go down our list of questions, and then just so we'll take whatever questions that we don't answer and we'll be putting them on a blog and having our experts from this panel answer those questions. So so the next question is, what are the main unmet needs in terms of pesticide formulations for drone applications? So who wants to take this one? Derek, Scott?
I mean, I think we've covered most of that. So the unmet needs are obviously issues around the volume of formulation, the reduction in or the specific droplet size that would be required, or the pressure that would be required to apply these at. So I think, as Scott touched on earlier, there is a lot of unmet needs and there's a lot of challenges that need to be achieved in order to drive this technology forward and increase uptake. But I think we've covered most of the sort of key issues around that already.
Okay, Scott,
Yeah, I would just add one quick thing, Renee, is don't forget the regulatory component. There's a lot of formulation development needed. There's a lot of unmet needs, as the question states. But a lot of those unmet needs, even if we can fix them, may require regulatory intervention as well, because you may need new products, new droplet size, new labels. Don't dismiss the unmet need of to get around the regulations. They're going to have to be worked out together.
Tung, did you have anything you wanted to add to that?
I think Scott just mentioned what exactly I want to say. It's really important.
Okay, thank you. All right, next question is, I live in Asia. Outside of China, drones are a novelty and a fad. Outside of China, it may be 10 years away. What are your thoughts about key adoption criteria for different countries? Rachel, is that a question for you?
I mean, yeah, again, it's just a case of the farm sizes, the demand needs to be there. A lot of farmers in some of these countries, they're still lagging behind just in technology, even the types of pesticides that they're using, still using very generic products. There's still a lot of opportunity there for them to advance just to more proprietary products before then advancing into drone technologies. And it's a case of whether or not these drone companies see the potential in these countries, whether they want to invest there, or whether they're going to switch their focus over to more Western regions as they see adoption increasing there. So I think it's a lot of education as well is needed in these countries to drive demand at the grower level before we see adoption coming up really quite quickly. Regulations as well, a big part in this. The countries have to regulations have to open up to allow drones to come in to a degree before we can start to see adoption lifting off like we have in Japan and as we're starting to see in India.
Yeah, I would say it's not just China, because they're heavily used in Japan, and also, as Rachel touched on, they're also becoming much more common in India as well. And I think it leads a lot to not just agricultural development, but also economic development is a big factor in this. So what you're having is labour costs in these countries are increasing to such a point where the investment in the drone technology is a tipping point towards cost saving, rather than having to use manual labour in this type of endeavour. So I think what you're seeing is economic development is a big factor behind it, as well as agricultural development. So when you start looking at labour costs rising, or you start looking at even just general costs, energy costs start to rise as well, where fuel for a sprayer or a tractor to cool the sprayer, for example, starts to increase. Then there comes a tipping point where the use of the drone is probably more profitable than using the old techniques. So I think adoption of most technologies in agriculture comes down to, is it going to save the farmer money and be more efficient? Drones have the capability to do that, but in some countries, the use of manual labour and the cost of fuel is such that it hasn't reached that tipping point yet where drones are more attractive. But Japan, China, India are the key ones in Asia that are adopting it right now.
Okay, great.
Yes.
Arthur, did you want to add anything to that, or anybody else?
It's kind of a tangent, but like I think on the topic of US adopting drones, it's not that there isn't an appetite from what I've seen. I don't think like they're just a fad, for example. I honestly think, and this isn't to talk crap about the FAA, but I think the regulations are holding a lot of people back here. And it's the fact that in the US we have a very robust FAA, right? So the aerial regulations here are very strict for good reason, to keep us all safe. But it's a gargantuan organization and it takes a long time to turn like a massive ship like that, right? So I think that's been slowing the adoption more than anything, not appetite or not our ability to utilize them or anything like that.
Tung, did you have anything you wanted to add?
Yeah, just because this question is from the person who lives in Asia, so I just want to give some input that actually from last year and until now, most of all the country in Asia, they try to catch up with this. For example, Philippines, I mentioned before, they have the list of the registered pesticide and also the guideline for spraying drone in agriculture. Malaysia has the agricultural payload list, which is the list of the pesticide for spraying drones and also other substances. Vietnam also has the guideline. India, of course, they have the SOP and the list of the pesticide. South Korea also, and the country like small country like Thailand or Indonesia, they also have the guideline for the for training regarding the drone operator. So you can see that more and more countries in Asia, they try to speed up their own system because they know that it is a trend, and sooner or later this technology will be kind of deploy in this region. So I would encourage you, especially the person who asked this question, that if you're really interested in this topic, there will be plenty of information for you. But just because of each country in Asia, mostly they publish the guideline in the local language, that is kind of the difficulties. But else, I would love to discuss about this topic later. Yeah.
Great. And also just to encourage that person, there is an article that you wrote in the September ABG Direct that is coming out September 1st on drones. All right, everyone, thank you so much for this discussion. For our viewers, there were the questions that we didn't get to. We will be taking those questions and posting them on a blog, and you will get a recording of this webinar as well. So thank you, everyone, again for joining on this panel, and have a great day.
Thank you, Renee.
Everyone, bye. Thank you.
Thank you.
Thank you.
Bye-bye.